Hey guys, welcome to Samuel M's studio. This week we're going to be speaking about Tekla Structures. On Instagram, I actually got a DM from someone. I think they follow me on LinkedIn. So on my banner, I think I'll just post it, a photograph of it. It does say that I'm a architectural design student, an interior design student, and Tekla structural steel detailer, and a lecturer in that as well. So it is quite an interesting part of my journey because both worlds are starting to merge. My journey within structural steelwork detailing, because I do continue teaching that, and my newly started journey of interior design and interior architecture. They are both, coming together, which is really cool. And I believe that the structural steel has been so much of a foundation, and this is where most of my experiences started, with structures and building and construction. So the two are coming together. So I answered the question, but I thought, what, let me also do a video where I explain what Tekla Structures is, and what is its relevance to a structure, to a building, and to interior architecture. Very different. This is super, super different from interior architecture, interior design, but same. I wanted to say same WhatsApp group, but same category of building. However, different discipline. Let me put it that way, because the interior architecture would be more the finer, final touches of the building process, and the structural steel will be the initial stages. Right. So yeah, in this week's video, I'll just be breaking down what what Tekla Structures is, and how it works, the software, and what a steel detailer is, because I'm a steel detailer by training, and now I'm still continuing my studies towards interior design and interior architecture. But what is a structural steelwork detailer? Because it's one of those specialized fields within engineering. When you say structural steelwork detailer, people are like, what is that is exactly? So I'll be breaking all of that down and just explaining it in a way which I hope is comprehensive, so that yeah, we may have an idea of what it is, and perhaps you're interested in learning more about Tekla Structures as a software. I'll also attach some information for us to be able to follow up and learn a bit. All right, let's start with the software. So Tekla Structures is a BIM software. So BIM is building information modeling. So building information modeling allows us to integrate information with a model, and we're able to share information across different disciplines. For example, if a warehouse is coming up and it's going to be erected and constructed, we'll start with the process where there's communication between the client, the architect, and the engineer. So the client will express their need for a structure, and then the architect will come up with conceptual sketches. Then once the final sketch has been approved, the engineer will check for the strength. Then once everything has been approved and the final concept has been approved, construction stage will now take place, where an engineer or an engineering firm would then consult with a detailer or detailing office, or if they have a detailing department, then detailing would start. What is detailing? Structural steel detailing is the process of adding information that will aid the fabrication of steel members. So as we see in our normal structures, we've got different types of members, right? For example, just looking at this, we've got your columns, we've got your rafters, and we've got beams, right? That's a column, a vertical member, your rafter, your purlins, all these different members. So they will then be drawn by the structural steel detailer to size. Detailed information will be added that will aid the fabrication of this member. So they'll add information about the drilling of holes, the cutting, the welding. Then once all of that information has then been established, the detailer will create a model. Detailers of the current age use a lot of technology, different detailing packages out there. Tekla Structures, which is what we'll delve into today, is one of the detailing packages. And after the information has been put in and the detailer has basically built the whole built the whole structure, so it would look exactly like what you're seeing in front of you. This is what a detailer would do. I would sit and then put this together. This model, by the way, has been put together by Trimble, which are the that's those are the people that provide Tekla Structures. So this has been given as a reference model. So once all of that information has been established, then the detailer would then model according to all the specifications. Remember, when we model according to specifications. So something that is extremely important in a building is the connections. So, we'd get the sizes from the architect and the engineer. Sometimes we get the connection details, then we create connections in the model. Connections are those facilitate the joins, the joinery between the steel members. So say for example we've got this rafter over there, and we have a column. The two need to come together in some way or another. So we have a plate over there, and this is part of a beam that has been cut. We call it a haunch, and it will facilitate a connection. So this is a connection. And this is a connection as well that you're seeing over there. And at the bottom of the column, we've got a connection as well. So a detailer puts in all the connections that are according to standard and according to the engineer specifications, and ensures that everything is as per requirement. And then after the detailing process has been complete, drawings are then put together. Three sets of drawings are done. Firstly, drawings to aid the fabrication, drawings to aid the joinery. We call them assembly drawings, and then drawings to erect the structure on site. So those are the three sets of drawings that a detailer puts together. A detailer does not just put drawings together, they also put together documents that aid fabrication. So they put together material lists, spot lists. If it's at a stage where tendering is still happening, they'll also put tonnages together, but that's also summarized in the material list, and that goes to the department that works with estimation. Right. So that's what a detailer does essentially. And the link between the detailer or the detailing process and architecture or interior design, these are two processes that are very far apart from each other, however, linked. So in my current studies, I'm learning, and I've got a subject called building construction. And in building construction, we basically learn, it's like the basics of structures. We learn from ground level about foundations. So in my model, this is how we used to show foundations, right? These are foundations. We learn about reinforcement, right? And with us, we used to call it rebar. So this is how we would show reinforcement. So the two are very similar. However, for an interior architect or interior designer, you are just required to have an understanding of how the building is put together, the processes and the standards. You are required to understand that. So it's very important to understand that in your design process and also in your planning process as well, to be able to establish what the benchmarks are. So yeah, so that's it. That's what a detailer does. And the link is that, one of the responsibilities is done, at the beginning, and then one is then, established while the process is then built up. So the detailing will happen right at the beginning while the structure is being put up, and the interior design also starts, you would start planning early, but then you would really start seeing it once the structure has, been built or put together on a site. So interesting. It's a very interesting part of my journey where both of them are coming together now, because my knowledge of structural steel, I mean, it remains. It will always be there. And now I teach that as well online, so it will always be there. And with building construction, sometimes we visit, even with the lessons, we visit, some of the practices that we used to do, in structural steel. Right. So that's the link. That's the link. That's the link between the two. And the software itself really is such a user-friendly software, very easy to learn. So as you see here at the top, these are your basic commands. This is how you would insert your column, your beam, your poly beam, your curved beam. So when you click on, the section itself, it actually gives you a prompt to create a steel column at the position that you pick. The bottom and the top level will also be established. And to create a steel column that is not vertical, you would then use create steel beam command. So that different commands, very similar to other software, building information software, where use your basic commands to put in your structures, your not just steel members, but your individual members, and you're able to manipulate the properties of the member itself, so that at the end you get your required product. So very very similar, and quite a good software. It's widely used across the world. And there's a high need of structural steelwork detailers, skilled structural steelwork detailers. So it's one of those quite good fields to be in. A lot of development happening, especially because we use a lot of technology. So I'm just going to walk you through this model, and we are just going to look at what the software does and also understand the types of processes. So this is a portal frame. We call this a portal frame, and portal frames. These are the skeleton of most buildings. So if you were to take away your bricks, your drywalls, your sheeting, all of the last stage materials, that material that we put at the finishing, or the last stages or final stages, this is what you see in front of you. So you would see just columns. These are columns, are the vertical members that take loads and then transfer them directly into the foundation. That's what you would then see, and you'd see all the connections of these members. So this is a portal frame. Portal frames are used for different structures and purposes. You would either use them for warehouses. You can also use them for hangars, for big aeroplanes. But with you are not limited in terms of what you can do with the software. You can also create supporting structures for. I remember we once did a conveyor, that's for more mechanical, mining type of use, where coal was transported from a starting point all the way into the part where it was put into the burner. So you can do so much with a software like this. And an alternative to a 3D modeling package would then be a 2D modeling package. 3D really nice because you can see all the clashes. So if it happens that there are clashes in the model, you are able to detect them early, and fix them. So it also has a clash detector. Tool to it. So you select everything and it tells you if there are any clashes. Clashes do arise a lot in construction. Say, for example, and it happens a lot where there is an interdisciplinary connection. So for example, if mechanical and electrical and structural are all working together on one project, then clashes might happen where the piping might clash. So clashes are a thing, and they are a reality. But then in engineering we have that type of mindset where if things happen and we encounter problems, we look for solutions and we move forward. We are not going to dwell on a situation, be like, oh no, there's a clash. And I think that's something really that I've also just taken into my personal life, that if things go wrong, just find a solution and keep on moving, keep on moving, keep on moving. Don't dwell on the problem, but try to establish a solution and move forward. So yeah, that's it. And in this structure, basically, that's the entrance. We spoke about what a portal frame is used for, and you can see that it spans across one, two, three, four, five, six bays. So if I were to look at it from the top, this is what it looks like. If I were to get the dimensions, we can then see this is the measuring tool, the distance, horizontal distance. That's what I'm going to measure from point A to point B. We can see that each bay is spaced at 5,750, and we have established that we've got one, two, three, four, five, six bays, and the total length of that is 34,500. And yeah, and then if we want to measure this side, we'll definitely measure the vertical distance, and we'll take the distance from there to there, and then we have 18,000. Right, and those are the measurements. And yeah, interesting. I could say a lot. I could say so much about the software, say a lot about structural steel. Yeah, that's a part of my journey. That's where I started, actually, before I got to interior design and interior architecture. So I started learning I started studying structural steel detailing, went into structural engineering, working on site and with consulting companies, until I got to a point where I was like, you know what, I'd really like to also study further. Then I studied a bit of quality control, which is very linked to this. But there we learned a lot of metallurgy. So metallurgy is the study of material science, or the study of metals. So we learned a lot of the chemical compositions, but also the that happens, especially in the industrial side. So on a site, basically, like when the welding is then done, the types of checks that are done, etc., etc., etc. And that was through the South African Institute of Welding. Yeah, so that's it. And that is how one got to where they are right now. I think I've always been a creative, but I didn't know what outlet or what path to take. I knew there was architecture, but yeah, I don't think I was encouraged to go into that field until right now, where I found courage to follow that, and I still really enjoy just talking or reading about what is happening in structural engineering and the software applications. As a huge fan of building information modeling, it's always interesting to see the developments that are taking place in that part. So yeah, that's it. If we can just name a few of the members that we see here, we see these are columns. This is a base plate, and this is a rafter. This is a purlin. This is a gird, right? And what you're seeing on these sides, these are basically to support the sheeting. This is a gutter, right? That is for drainage. And this, so we've got two parts of the structure. So this is what we call the eaves end, and this is what we call the gable end. So from grid line 3 to all the way to 1, that's what we call the gable. From grid line G all the way to A, that's what we call the eaves, right? And the beams that connect on this side, these are called eaves beams or struts. Struts because it's a member that is loaded in compression. And yeah, so load path is something that we analyze a lot. We look at how the loads are how the loads are transferred from the loading point all the way onto the foundation. So that's when we start looking and evaluating the need to add members like bracing to ensure the rigidity of structures. Yeah, so that's Tekla Structures. That's why I use Tekla Structures or have a background in Tekla Structures. If you are perhaps interested or curious about Tekla, you can just pop a question in the comment section and yeah, I will answer that. But exciting times for me and my classmates. Yeah, because we are actually this Thursday I'm going to site. So I'll be following the construction process. I am sure. I think I will take photographs or just record the process, and then you can follow on the WhatsApp channel, not the WhatsApp channel, the Instagram channel or the Instagram page. Yeah, and maybe I'll also post some highlights here on YouTube as well. Guys, have yourself an excellent week. Have a good one. And yeah, let's keep interacting. And please do not feel shy to comment right here. Yeah, if you do have a question, or but if you feel more comfortable with a DM, that's cool. I also don't mind that. But yeah, have a good one, and please don't forget to like, comment, and subscribe. I highly appreciate that always.